Similarity in shapes means that the shapes are the same, but they could be of different size. Now, to prove that two triangles are similar, what we need to show that is that there's two angles that are the same, and then that would mean that the third one is the same because angles in a triangle always add up to 180. Now, if we look at this diagram, we can see a triangle ABC. We can see another triangle DBE. Now, what we can do is we can show that two of the angles in the triangle DBE are the same as two of the angles in the triangle ABC, and that will mean the third one is also the same. Now, if we look at the angle ABE, which is here, that angle is actually in both triangles. So it's in the triangle DBE. It's also in the triangle ABC. Now, that means we have at least one angle that's the same. Then if we look at these two lines, the arrows are telling me that these are parallel. So therefore I can see that these angles here are corresponding angles. So therefore these two angles are of the same size. So now we've shown that the angle ABC in both triangles ABC and DBE is the same. And we've also shown that the angle BDE and BAC are also the same. Therefore, the one angle left will also be the same, but we can see that using parallel lines as well. So what that would mean is that this angle here is equal to this angle here. Now the next stage is to write all this out. Now what we can say is, so angle ABC is in both triangles ABC and DBE. The next thing we can say is angle BDE is equal to angle BAC, and this is because they are corresponding angles. So corresponding angles are equal. Okay, and now what we've done is we've shown that there's two angles that are the same in both triangles, therefore the two triangles are similar. So the two triangles ABC and DBE are similar. In this example, I will first show that the two triangles are similar, and then we will find the lengths of the missing sides. So to show that they're similar, we can see that this angle here, ACB, is equal to the angle DCE, and this is because they are vertically opposite. So vertically opposite angles are equal. So we can say that angle ACB is equal to angle DCE, and this is because vertically opposite angles are equal. Okay. Now we can also see that we have parallel lines. Now we've got parallel lines going this way. We've got a line going through both of them. Therefore, this angle here is alternate to this one. So these two angles will be equal. So we can say that angle CDE is equal to the angle CBA. And this is because alternate angles are equal. So angle CDE is equal to angle ABC. And this is because alternate angles are equal. Okay, so we've shown that two angles here are equal to two angles here, therefore the two triangles are similar. Therefore we can say that there is some scale factor that if I multiply to this triangle, it makes us this triangle here. So how to find that? Well, we can see that this side here, the 7.2, is corresponding to the 6 here. So what we can do is we can say 7.2 divided by 6, which will give us our scale factor, which is 1.2. Okay, now how can I find the missing sides here? Now, if you notice that I've got 10.8 here and 7.2 there. Now I need to check if 10.8 is corresponding to this side or that side. Now what I can see is I've got this angle here, which is in between the two lengths 10.8 and 7.2. Now here, this angle is corresponding to that angle there. Now that would mean that this, if this was corresponding to the 7.2, then this length here would be corresponding to the 10.8. So to find this length here, what I would have to do is 10.8 divided by my scale factor, which is 1.2. So let's do that. 10.8 divided by 1.2, and that gives us 9. So this would be 9 centimeters here. And to find the length CE, what I would do is 8 times 1.2, which is going to give us this one here. So 8 times 1.2, and that is 9.6. Okay, so this is going to be 9.6 centimeters. Here are the questions that I'd like you to answer for the next lesson. Now, when you're proving that the triangles are similar, please write out the proofs in the same way that I have, so use the same notation. And for question 3, you must write it like a proof as well. So you have to write it like a proof and justify whether triangle BDC is similar or not similar to triangles ABC and ABD.